Alright, so we're on to a new topic in these next set of videos. This is all to do with similar shapes. So to start off with, just a couple of definitions, things to be aware of. So let's just get straight to it. So congruency. So congruency is when two figures are said to be congruent if they are exactly the same shape and the same size. So that shape could be moved from one spot to another, it could be rotated. So for instance, here we can see that we have that 10 centimeters, there's 10 centimeters. And those two sides would also be 10. And we've got 4, that would be 4. So would that, and so would that. So all I've taken is that rectangle, moved it a little bit, rotated it. They are congruent, they are the exact same. Similarity is what we're going to be dealing with, and that is when two figures are said to be similar if they are basically the same shape, with one being an enlargement or a reduction of the other. Two similar shapes will have their corresponding angles equal. So we can see here at the bottom, because this is a trapezium, these two angles down here are the same. And in turn, in this enlarged form, it is also going to be identical. And same with the top up here. Those two are the same, and these two up here are also the same. And it must also have their corresponding sides in the same ratio for them to have the same scale factor. So if I was to be looking this as going from that smaller to the larger, how I often do my scale factor, I like to look at it as the new over old. So that's my old shape, and this is my new one because I'm moving to it. So if I think about all my sides, I've got the 4 centimeters here, which goes to 8 centimeters. So that would be 8 over 4, because it's the new one over the old one. And then I've got this 3 centimeters and the 6 centimeters there. And at the bottom, I go from 6 to 12. And all of these, when I simplify it, come out to 2. So that is why those two shapes there are similar. The angles, the corresponding angles are equal, and the corresponding sides are all in the same ratio. So let's take a look at a few questions. So, example, the pairs of shapes below are similar. Calculate the length of x. So the first thing I need to do is identify the scale factor. So again, my scale factor is new over old. And your new shape is always the one that has the unknown. So that's got my x, so that's my new, which makes this my old. Then you will look to see what pairs of sides you know both the information for. And that is going to be this length down here at the bottom, because I know both of my numbers. I can't use these two lengths because one of them is my unknown. So I'm going to use the 12 and the 39. So it's my new length over the old length. And then you always want to simplify it. If you have a calculator, you can just put it directly in. Otherwise, those two there can be divided by 3, which will give you 4 over 13. So then to find out x, I'm going to take the scale factor and multiply it with the old side. So the old corresponding side. So I'm going to take that 4 over 13 and I'm going to multiply it. The x is there, its corresponding side is that 26 there. And then that just comes out to 8. And that'll be 8 millimeters. Okay, so let's take a look at this next one here. So again, wherever my x is, or wherever my unknown is, that's my new. So that's my old. So using my scale factor of new over old, I look at the corresponding sides I know the information for. So that's this 1.4 and the 17.5. So that's going to be 17.5 over 1.4. Whichever else I put it in the calculator for it to simplify comes out to 25 over 3.2. So then my x, taking that scale factor, multiplying it with its old corresponding sides. So the x is at the bottom there, and at the bottom here is at 3.2. And so that just comes out to 40. So 40 centimetres. So that's just a basic similar shape, how to use the scale factor. I've got 4 more videos that's going to follow on from this, and that's going to keep building on this idea through each step of the way. Let me know if you have any questions, and good luck with the work.